Right, let's have a look at this one. Question 6 from the 2018 paper. 16 girls and 14 boys went on a school tour to Barcelona. The weight of each student's bag in kgs is shown in the table below. So there's our girls and their weights, and boys and the weights of their bags. Part A, the mean weight of the girls' bags was 8.6 kgs, correct to 1 decimal place. Work out the mean weight of the boys' bags, correct to 1 decimal place. Okay, so from last week, we know that mean is another word for average. And we get it when we add up, in this case, all the weights, and we divide by how many we have. And so in this case, we'll be dividing by 14 because there's 14 boys' bags here. So plus 8.7 plus 8.8 plus 9.2 plus 9.4 plus 9.5 plus 9.5 plus 9.7, 9.7 again, and 10.5. And we divide it by 14. Okay, in an ideal world, you would write it out like that, because what you're doing there is you're showing any corrector of your paper, let that be a teacher or an examiner down the road, that you know what you're doing. You know what the mean is. So even now, if I make a mistake putting it into my calculator, as I often do, the examiner knows that I knew what mean was. Plus 9.4. Plus 9.5, plus 9.5 again, plus 10.5, all divided by 14. And for that, I am getting 8.72. So to 1 decimal place, 8.7. Okay, so when I get an average as like this, I look at my data and I see, does that make sense? So it's 8.7, so round here. So yeah, it goes down to 5 and up to 10, so 8 would feel like it could be right. Okay, so that's the mean. Part B, use the data in the tables above to complete the following frequency table. Okay, so all I've done is I've copied in that data here down to the bottom so we wouldn't be flicking over and back, okay? And I want to do the frequency table with you. So we're grouping them into categories. So bags that weigh between 5 and 6, 6 to 7, 7 to 8, and so on and so forth. That's a frequency table. So there should always be a key with the frequency table that explains, for example, if a bag is 6 kgs, which one of these two columns does it go into? Okay, same for 7, same for 8. Okay, so there's often a key that comes with the table or a note down here at the bottom. So it's telling me 5 to 6 means 5 or more, but less than 6. So in other words, if I get a bag that weighs 6 kgs, it's going to have to go in here. Okay, so the number of girls' bags. So one way of doing this is to do a tally table. It's also really useful if you get asked to do a histogram, to do something like this. So I'll show you what I mean by that. So this one is 5.8. So I'm going to put one in there. 6.3, one went in there. 6.9, one went in there. 7.6, one went in there. 7.8, one went in there. It's not as critical in this one to do a tally table, which is why there's no tally column in it, because they're already in numerical order. 8.1, 8.7. Do you see what I mean? So if these weren't in numerical order, you would cross them off one by one and just put it a 1 into the right box, okay, and so on and so forth. I'll just do the 9s to show you how to do the tally table while I'm at it. So 9.1 is here, 9.4, 9.5, 9.6, and then for the 5th one, you put a line through it. There's the 6, there's the 7. So when you're looking at it, you know that's a bank of 5, 6, 7. Okay, so what you do then is he's 1, he's 2, of course, he's 2, he's 3, he's 7, he's 1, and he's 1. No, I can't count, obviously, because 9.8 is in the other one. He's 0, and he's 1. So then I'm going to add them up, 2, 4, 5, 6, 7, 8, 9, 10, 15 and 16 girls. Okay, and let's do the same with the boys' bags. I won't bother doing the tally table here now because there's no need. So 5.9 is 1. 6.8 is 1, that's fine. 7s, I only have one of them, 2. 8, I have 1, 2, 3, 4 8s. 9s, I have 1, 2, 3, 4, 5, 6 9s. 1 10 and no 11. Okay, so that's your frequency table. Owen says, in general, the girls took heavier bags than the boys. Based on the data above, is Owen correct? Give a reason for your answer. The girls took heavier bags than the boys. I don't think I agree with that. I think they look about the same. There's one bag each that's really heavy. There's 3 light bags, or 2, 4, 5 light bags there, 3. Let me go back and check the means. 8.6, 8.7. Okay, so I'm going to say no, Owen is not correct, as the means are almost the same. That's why it's great to measure, or to, when we have calculations for the mean, the mode, or the median, because then it's really easy to do comparisons, okay? 8.7 and 8.6. Okay, we could have also talked about how the weights were distributed in the frequency table and the fact that it's almost balanced. Most of the bags' weights are between 7 and 10. That would have been a perfectly acceptable answer. Okay, or generally anything you can think of. Okay, part D, the table below shows the length of time it took the students to get through security at the airport. So we've time 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. Number of students 4, 8, 11, 6. Yeah, that's fine. Note 5 to 10 means 5, but less than 10. Draw a histogram to represent this data. Label each axis clearly. Okay, so there's some, I suppose, rules about histogram that you need to know. So the first thing is something I can mix up every now and again, depending on the last time I did a histogram. Okay, the widths of the bars need to be the same. Okay, so that's really important, because a histogram, when you look at the bar, it's all about the area under that bar. So you see the way these are going up in 5s, it means the widths here have to be the same to represent that, I suppose, that gap of 5. Okay, if I didn't have 20 to 25 and 25 to 30, so you see the way up at the end there now, I have just gone, okay, what happens if I just had one box up here that was 20 to 30? Okay, well then you would do a box that was double the width. So you could see that that represented an interval width of 10. Okay, so that's the first thing about histograms. The second thing about histograms is that the bars all touch off each other. Okay, that's what's different in a bar chart. The bar chart has gaps between them, and that's the bit I mix up, the bar chart and the histogram. Which one has the gaps? So a histogram is no gaps, bar chart does. Okay, next thing that's really important is that everything gets labeled. So you must label your x-axis and its units. Your y-axis tends to be frequency. Okay, in our case here though, it will be number of students. Okay, so basically it's the frequency at which something occurred. Okay, but you'll get, if you're asked to draw a histogram, you'll get your axis here. So the x-axis for us will be time in minutes. Okay, and the y-axis will be number of students. So typically x-axis first, then y-axis. And every histogram needs a title. Okay, you can't really draw a chart without having a title for the chart. Okay, so there are all the tiny things you have to remember about histograms, or you get docked marks. Right, so let's proceed. So let me grab a ruler, okay, and I'll try drawing this online. I just have my ruler here, and we try it. Right, how many boxes will we leave for each one? So we have 1, 2, 3, 4, 5, 6 bars. 3, 6, 9, 12, 13, 14, 15, 16, 17, 18. Or I could go 1, 2, 3, 4 boxes. Let's try 4 boxes and see do they fit. One, two, three, four, five. 1, 2, 3, 4, 5, 6. Just okay. Now, of course, there's nothing. I'm just going to make my line thinner. There's nothing stopping me extending on that axis like that. Okay, so what did I do there? Well, I did nothing more than just figure out what width would make sense to make each bar of the histogram. Okay, you tend to try and make the most use of your chart space, but of course it needs to fit. Okay, we have to go all the way up to 11, I see here. So I'm thinking we might be going up in ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so we're going to go up in ones. So each box up is going to represent one student. Okay, so the first one is 4 students. Okay, so let me just mark these. So there's normally not space to write in each one. Make that one a bit thicker. 6, 8, 10, 12. So each box is still representing 1, but I suppose I'm only writing the numbers in months, okay? So this one then is 5, 10, 15, 20, 25, and 30. Let me label my axes before I forget. So time in minutes. And swing around my page. Number of students. Okay, so the hash symbol is maths language for number. So number of students, and they've already labeled my histogram as length of time taken to get through security. Okay, so I think I'm ready to draw now. So 5 up to 4. Okay, between 5 and 10 is 8 students. So let's draw him in. Okay, between 10 and 15 is my 11 students. I'm sorry now, the ruler keeps slipping on the screen because it's a screen, so that's why my lines are a bit jaggedy. So sometimes I write the number here as 11, 8, 4, and then it can be really easy to see. So 6 students is across here. Zero students for the next one and 1 student for the one after. So just a small little box out here. Okay. So I hope that makes sense. I hope that's okay for you. There's 10 marks for that to be able to draw your histogram, so you can see it's well worth knowing. You get docked marks, for example, because I have the marking scheme here in front of me, you get docked marks if one or both axes are incorrectly labelled or not labelled, you get docked a mark. If the time scale is not shown, so in other words, the minutes, you get docked a mark, and so on and so forth, okay? So yeah, that's your histogram. So really good to be able to draw it. Right, the table below shows the amount of money that the 30 students spent at the airport. Okay, so again, up to 150 and how many students. Note 5 to 10 means 5 or more, but less than 10. Use mid-interval values to estimate the mean amount of money spent. Give your answer in euro correct to the nearest cent. Okay, so a mid-interval value. So if you're going to find the mean amount of money that people spent on a frequency distribution table like this, it's quite hard the way it's written, because of course this student here, this one student here, could have spent anything between 50 and 100 euros. Okay, and you've no way of knowing, is it as low as 50? Is it 51? Is it 60? Is it 75? Is it 90? Is it 99? Okay, and so on for all of them. So to get around that, we use what's called mid-interval values. So we find the middle point between all of these intervals. So in other words, between 0 and 5, the mid-interval value would be 2.5. Okay, so how will I get it? 5 minus 0 over 2 is 2.5. Okay, so the mid-interval value here is 2.5. I might write it in a brighter color so you're able to see it. So if I put 2.5 in there, then 5 to 10, 10 minus 5 over 2. So basically you're getting halfway between these two. Okay, so we're getting 7.5 for the mid-interval value here. Okay, and it's actually quite hard to read, so let's move it down here. So we've 2.5 here, we've 7.5 here, 10 to 20, halfway between them is 15, 20 to 30, halfway between them is 25, 30 to 50, halfway between them is 40, halfway between 150 is 75, and 125 is a halfway between 100 and 150. Okay, and for any of these, you can do the big number minus the small number over 2 to figure them out. Okay, so how do we get the mean then? Well, if you remember from the last class, or maybe we didn't do it in the last class, it's the number of students by the value here. Okay, so you have 5 students, each of who are spending what we're going to say 250. Okay, taking the average. Okay, so you could go 250, which is this value here. It's the mid-interval value of this, plus 250, plus 250, plus 250, plus 250. Okay, that's those 5 students, 1, 2, 3, 4, 5. Okay, because remember the mean is add them all up and divide by the number of numbers. We have 30 students, so we have 30 numbers up here up the top to add up. Okay, or is there an easier way than writing out all of this? Well, yes, there is. Okay, you can say I have 5 students, each of whom is spending around 250. I have then 4 students who's spending in and around 750. So you multiply 750 by those 4 students. I have 7 students who are spending 15. I have 8 students who are spending 25. I have 3 students who are spending 40. I have 1 student that's spending 75. And I have 2 students that's spending on average 125. Now be careful, you divide that by 30. Okay, so it's a very easy mistake to make that you would divide it by 1, 2, 3, 4, 5, 6, 7. Okay, very easy to divide that by 7. Okay, but I'll show you how to figure out that you've made that mistake. Okay, where does the 30 come from? If it doesn't tell you the total amount of students, it comes from adding up all of these. Okay, so if you add 5 plus 4 plus 7 plus 8 plus 3 plus 1 plus 2, you're going to get 30. Okay, so you add up the number of students here on the bottom. Okay, so let's put that into our calculator. I'm going to do it in 2 halves. I'm going to do the top on its own first, okay, because I want to use that for something else to show you how to spot that mistake. So 4 multiplied by 750 plus 7 multiplied by 15 plus 8 multiplied by 25 plus 3 multiplied by 40 plus 1 by 75 plus 2 by 125. And I'm getting 792.5 for that over 30. Okay, let me divide that by 30 then. So I'm getting 26.42 euros there. Okay, so I rounded to 2 places of decimal because that's money. So you always round it to the nearest cent. Okay, so that's your answer. That's the mean amount spent. Okay, so I did promise you I'd show you how you spot that error. Okay, so let me write it in red. Okay, so if you had gone 792.5 and you had made the mistake of dividing it by 7, 1, 2, 3, 4, 5, 6, 7 different divisions, okay, you would have got 792.5 divided by 7. You would have got 113.21. Okay, right. So always look at your answer and go, is that the average? Is that the mean? Okay, and 26 is here. So you can see it is roughly in the middle of my table. Okay, I have a few students here, a few students above it, and my average should be somewhere in the middle. When you get a value of 113, or worse again, a value greater than 150, 113 is up here. Okay, now there's no way that is the average value spent when the bulk of the students is down around here. Okay, and that's your flag for knowing sugar, I divided it by the wrong number. Okay, so watch out for that one in frequency tables. Okay. The next bit then said, use the values in the table to estimate the median amount of money spent as accurately as you can. Okay. So there's 30 students, okay? So median, let's write that down. Median is the value in the middle. Okay, when in order. Okay, so we order them from the lowest to the highest. Okay, now if we have 30 students, okay, our median is going to be in the middle of them. Okay, so it's going to be in the 15th and the 16th student. Okay, it's an even number. 30 is an even number, which means the median will be shared between these two. Okay, both of these numbers will sit in the middle. And if you write out the numbers 1 to 30 and just like we did last week, come down on median and come up. So let me show you what I mean by that. Like this, come down on 15 and up 15, you'll see 15 and 16 lie in the middle. Okay, so try that for yourself to convince yourself that it'll be the 15th and the 16th student. So where do they lie? Well, I have 5 here and 4 is 9 and 7 is 16. Okay, so I now know that the median lies somewhere in here because that's where the 15th and the 16th student lie. Remember, it's the value in the middle when in order. So I'm counting up from the lowest. Okay, so 5 and 4, 9 and 7 is 16. So 15th and 16th is at the right upper end of this table. Okay, so something like maybe 19 euros, 18 euros, something like that will be the median amount. Of course, you've no way of knowing, okay, because these are grouped data. Anyone was between 10 and 20 was put in here. So of course, all 7 of these could be bang on 10 euros each, okay? All 7 of them could be 19.99. You've no way of knowing. So you're just estimating, okay, as accurately as you can what you think the median will be. Okay, so I'm going to pick 18. 15th and 16th students lies in the top end of 10 to 20 euros. Okay, so that is my justification of my 18 euros. Okay, so I hope that makes sense. That can be quite hard to do, especially in junior cert level when it's perfectly okay to guess an answer.